Hi everyone. Today we are going to start section 10.3, and basically in this section we're just going to bring everything together that you learned in 10.1 and 10.2. So we're going to look at all the tools that you have used thus far, and they are going to help you sketch a graph of a polynomial function without a calculator, okay? Without is the key word there. So in order to do this, we can follow these steps below. There's 5 steps. First, we're going to find the y-intercept. Second, we're going to consider the end behavior. Third, we're going to find the real zeros and plot them. Fourth, we're going to plot any additional points found while determining the zeros. And fifth, we're going to sketch the graph. Okay, so let's look at this very first example here. It says that f of x equals x to the third plus x squared minus 16x minus 16. So our first step is to find the y-intercept. Well, our y-intercept is negative 16. Remember, it's just the constant at the end, or you can always plug 0 in for x and solve it, okay? Step 2, we're going to consider the end behavior. Okay, this is a positive, this is a positive function, and then the degree is odd. So it's positive, and it's odd. Now remember, we want to look at the graph to see if it's positive or negative to determine what the right side of the graph is going to do. Since it's positive, that means the right side of my graph is going to point up, okay? And because the graph is odd, we know that it's going to point in the opposite direction on the left side, so the left side is going to point down, okay? Next, we're going to find the real zeros. Now to find the zeros of a function, remember, we can just factor it out. So since there's 4 terms here, I'm going to factor by grouping. So I have x to the third plus x squared, and I have negative 16x minus 16. So let's go ahead and factor this guy out. We're going to factor by grouping. My GCF is x squared, so I'm left with x plus 1. Over here, I'm going to take out a negative 16, so then that makes the x and this one a positive. So then now these two guys match right there, okay? So then I have x squared minus 16 times x plus 1. Oops. And then I can factor this down even further. So then I get, probably drew all the little equal signs here. This is a difference of 2 squares, so I get x plus 4, x minus 4, and I still have x plus 1. So remember, we're trying to find the zeros, so we need to set this polynomial equal to 0. Okay, so then my x values, x is going to equal negative 4, x equals positive 4, and x equals negative 1. Now if we talk about multiplicity here, notice that all of these roots only occur one time, so we're not going to have any bounces or anything crazy like that. It's just going to go straight through the graph, okay? Step 4 says plot any additional points while determining the zeros and then sketch the graph. So let's go ahead and plot our zeros that we found. So, what was it, negative 4? Positive 4. And negative 1. Okay, so I know that this side, like we already said, is going to point up, and this side will go ahead and point down. Again, these all have multiplicity of 1, so we don't need to worry about any bounces or slides. All right, now we should remember that if this points up and this points down, okay, mins and maxes have to occur in between these points right here, okay? Those are your turning points. So we need to figure out what's going on in between these zeros and what's going on in between this set of zeros, okay? So what you can do here is you can use synthetic division to figure out what that coordinate point is, or you can go ahead and just plug in an x value back into this equation to solve for the y value. Now, we don't need to know the exact min and max values quite yet. We'll get into that later on in the unit. So just for right now, pick an x value that's in between negative 1 and negative 4. I'm going to choose negative 2. So if I do my synthetic division with negative 2, my coefficients are 1, 1, negative 16, and negative 16. So I get negative 2, what is that? Negative 1. Oh, yeah, no, I'm doing that right. Okay, sorry. Bring that down. -2, yeah, okay, oh, sorry, -14, so that is positive 28, right, yep. And then 28 minus 16, we get 12, okay? So I know that my graph is going to end up somewhere way up here, okay? Again, we don't have to be exact right now, but I know that this is going to be a maximum up here. Oops. We don't have to be exact. -2, 12. And again, this might not be the max, and it doesn't look like it actually is. So we'll do something like that. Okay? All right, now I'm going to choose +1 over here in between -1 and 4. So let's see, I have 1, 1, -16, -16. Bring down the 1, 2. 2 times 1 is 2, -14. -14. That is -16 minus 14, -30. Okay, so that's going to be like somewhere way, way down here. Okay, and again, doesn't quite look like that's going to be the minimum of the graph, but we're just trying to get a graph sketch for right now. Okay, so there's the first graph. All right. And we did sketch the graph after we found all those zeros. Okay, so that's kind of just the idea that we're getting right now here. Alrighty. Example 2. All right. So here we are actually in factored form already. So this is kind of nice, but except when we go to find the y-intercept, remember that's our first step. Remember, you need to multiply the root number, not the root number, the factored form number. So we have 2 1s right here. So you're doing 1 times 1, 3 times 3, and you're doing -2. Okay, which that equals, let's see, 9, so -18. Okay, so there's my y-intercept. Oh, I forgot to plot that over here on this guy. I'm so sorry. Our y-intercept was -16. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. -16. Okay, I'm so sorry, guys. I forgot to plot that on this graph right here. Okay. All right, we'll do better over here. Okay, so -18, let's go ahead and plot that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, there's my y-intercept. All right, let's find the end behavior. So it is, let's see here. Okay, so all these x's are positive, so we know it's positive. And then, since this is to the first power, right? 2 plus 2 plus 1 is going to give us 5, which is an odd number. So again, our graph is actually going to point up on the right, and because it's odd, it's going to point down on the left. Alrighty. Next, we have to find the real zeros. So actually, since this is already in factored form, I can just set those all equal to 0. So x equals -1, and that happens 2 times, right? We have x equals -3, and that happens twice. And then we have x equals 2, and that only happens 1 time, okay? So if you guys remember anything about multiplicity, we're going to have actually a bounce at -1 and -3. So there's -3, -1, 1, 2, and 2, okay? So, I know that the right side of my graph is going to point down, so I know I'm going to have some sort of bounce like this right here, right? And in order for this to be a bounce, actually, this will probably it will probably go like that as well. We'll probably do a little U shape down, and then it will probably come back up here. and go up, okay? If you guys go ahead and take a look, let's find what that -2 value is right there. So I'm actually going to do something different, and I'm just going to plug in -2 into the function. So we have -2 plus 1 squared, -2 plus 3 squared, times -2 minus 2. All right, so that is going to equal -2 plus 1, -1 squared, which is 1. 1 squared is 1. That's -4. So this all equals -4. So I have a coordinate point of -2, -4. So 1, 2, 3, 4. That's where this guy is, okay? And like I said, I know it's going to do a bounce right there, okay? Now, remember our y-intercept was -18, so this guy has to come all the way down through here, okay? And the only x value between there is 1. So I'm going to go ahead and find f of 1 as well. So that gives me 2 squared is 4, 4 squared is 16, and 1 minus 2 is -1. So what is 4 times 16? 64, so that's -64. Okay, this is really going to go off my graph, so I'm just going to kind of pretend that it goes all the way down there, and then we're going to come all the way back up through this guy, which that makes sense because the right side of my graph should be pointing up. Okay, so make sure that you're finding the y-intercept, plot that first, find your end behavior, get an idea of what the left and the right is going to look like, find your zeros, figure out the multiplicity, and then plot any points that are in between your zeros to get a good picture. Okay, that's it. Have fun with your homework.